Hi everyone, here's Simone. This is a new touch design tutorial, and today we're gonna build a fake particle system. The technique in order to build this guy, or what you want to build with this technique, I took it from Denis Novikov. The link to this YouTuber will be in the YouTuber touch designer developer will be in the video description, and you should follow him. Okay, with all that said, we go inside and we take a look into the network. It is entirely made in top, and now is driven by a circle, a blurred circle, but you can input any image. So we take a banana, and we're having a particle banana emitter things. It's not like proper particles, more like sand, we can say, but I like a lot the effect. Yeah, Unveil Studio. Yay. Okay, so let's take out the background, or yeah, just here, go to the end. Okay, let's speak a bit about how it's made. So main concept, it's a displacement. Okay, and displacement is driven by some forces that are generated by a blurred element. Okay, and the slope is calculating the radial force produced by this blur. The direction of the force is where you have full image, so it will be the center, and then go to where is empty or black. Okay, so there's no image. The slope is calculating this radial force, and here there's a 2D matrix rotation. Okay, later we see. That is actually making all the movement of the particles. Then this is just an image, so color. Okay, we are passing through a normal top, normal map top, and here it's something really strange. So we are taking the input of the image, that in my case is this one, but the width of the input texture in the contrast. Don't even ask why. Then some other mathematical operation to actually generate the fake particles. The mathematical operation here are we are taking the length of the vector. This is now mono, so it's a float, and we are dividing the whole back 4 to this with this, and we get this. Okay, speaking a bit GLSL things. Okay, with the rotation you can do this, so you can control the direction of the displacement with the mouse or with everything you want. And yeah, this is for maybe another tutorial. Okay, so first concept here. Okay, let's start with a bananas. Okay, then we have to go forward and start to build the forces. Okay, I want to have something that rotate, doesn't matter what. So we actually copy the code from this guy, and I will explain it kind of fast. Okay, so as you can see here, I have a 4UV in a box. Okay, so hope you can follow. The code is this one. Okay, this is taken from the book of shader, and actually we can clean it. So let's say that I don't need this guy. I don't need this guy. Thank you, Patricio Gonzalez Vivo. So this guy is one of the two authors of the book of shader. I never get this, so I guess it's to make a better calculation, and we want performance. I don't know if it's correct, so thank you, but I don't need you anymore. Thank you again. So now we can speak about the code. The code is easy, so we're creating the UV, okay, normalized based on the resolution. Then we are multiplying those, so we're making a bigger vector, and the vector is fract, okay? Taking the fractional component of a vector, it means that the vector is long like 3, okay? Then you have 0, 1, 0, 1, 0, 1. So you have 3 elements, okay? And here is long 2, so you have 2 elements in each direction, so 4 boxes, okay? And then we are outputting the image, blah, 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 okay. So easy. No, rotation, pardon, the most important things. The rotation here is added to the UV by creating a vec2, because the UV are red and green, so 2 value. We are applying what a circle. Okay, the circle is made of what? Of a cosine and a sine. So if you put it together, then you have a circle. If you smash inside to this function, a sine, a cosine, that are mathematical function embedded in the GLSF, so you can use it. You have a circle that turn positive, I guess you go to the right, negative you start to turn on the opposite side. The circle has been added, a percentage of the rotation is added to the ST, so our UV, and then UV rotate, bananas. Okay, how to use it? Remap. We want to remap the banana with our new things here, and we have 4 rotating banana that we want to mirror, and then we have this. That is fair enough. Let's start to build the forces. So we said that we need something blurry. Okay, then we drop a blur and we blur, something like that. So you need to see something, but it's better to have it clearly. So 432 is not those values. Okay, you can experiment. Okay, then we're gonna have also to those forces, we're gonna add other forces. Okay, so we attach a noise that we need just 2 colors, so we make it monochrome just in case, and input plus noise, and we take out the noise scale. We want just a bit of, and we want here we will use the red and blue channel, so this is why I add color. Okay, let's blur again just to be sure we are blurring enough, and okay, let's attach a slope. Okay, in this case the 0 is 0, so in our mental position. Okay, then we take a feedback because we want to actually engage the feedback displacement chain by doing this and that. Let's say 2 here, and let's leave it like this for now. Okay, then we have to set up the displacement guy. So we said that our 0 is 0, so 0 is 0, and let's say repeat because it's better when moves, and the offset displacement weight, let's say 0.1 for now. Okay, put a null. So we have an end to our chain. Let's displace it, display it and displace it. Okay, smash it bananas. We actually want to, there we go. So you see, we are displacing the bananas. Now with some forces driven by these things here. Let's move also this guy with the most common expression touch designer, abs time dot seconds divided something, and of course I didn't write it correct, seconds, missing a D, so now also the noise is moving and we had some more motion. Okay, so like this it's a bit like ugly because actually we are losing the banana, so it's not good to lose a banana. We want to put it back because banana are important, they're rich of potassium and they're good for the brain, so we want to keep it, and we want to actually here so I don't know, something like that. So what did I write? Oops. Okay, so just a tiny bit of banana. Then we wanna do an over because we want to put it over the actual banana, a little bit of banana, and this tiny bit in a feedback chain become what we need. Nice. Okay, so let's actually add a null here to make a bit of space in the beginning, and let's make the banana rotate to 180 degrees. So because now we're speaking about mathematics and things, let's be mathematical also here. So we can use an expression and create an LFO without using chop. So because we're good in math, we use math, and then for the math we take the sign, we smash inside something that move like uptime dot seconds, okay, and this guy now is going 0 1, actually minus 1 1. We multiply this minus 1, it's fair enough for me. We multiply this for 180, so we create the LFO and then we use it, and it's rotating. Okay, nice. Okay, so we are arrived here and we have a rotating banana. That is fine, but we want to build something else. So we continue by making the magic. We drop a normal map. Okay, and we leave it as it is. We attach a level in which we have to get the input image of the input width from this texture. Okay, smash it here. So me dot inputs 0, because it can be more than one and we want to read it as an array, so we want to take the first one, and then we ask for the name of the things we want to get with. Here we go, and we have this. Pretty nice. Then a little bit of mathematics here again. The mathematics here again needs to be done with a math. Okay, we plug it here. So we want to combine all the channels, so red, green, blue, and alpha, and we want to have the length. Okay, we are not satisfied because we want to have this as a really good float. So now you see a white screen because all the value above 1 cannot be displayed. It's white. So now we want to divide the guy there with a composite. Selecting divide, and the mathematical operation is dividing the guy for the length. And we have this. Bananas. Okay. We create this guy. What else? Yeah, we can then change the banana with something that make more sense, like a circle. Oops, like a circle that needs to stay in the middle of a texture. A big, I don't know, like this, and we plug it here, and then we have a circle. Okay, now for empty circle. We want to say that we need something blurry, so we start to blur it here by engaging a bit of softness. Okay, and something is happening. And then we want to also make an edge, because this is kind of important. The edge needs to be red. Then we also other color, then we explore and we put it on top. Okay, so then we are reaching more or less what I was doing in the other one. You have just to make the circle move. Yeah, actually you can make a circle move with the same expression, like so. I'm going to scale it times 4, 0.4. So yeah, it's going a bit fast, but I can then divide this from 5. Okay, and then it's moving. Other things you should know, in the displays, okay, we can add more motion to the system. I don't like it, maybe this is a bit too much motion, so we can decrease it like that. Okay, here we go. And then you can play around with the weight, because the weights actually move this guy into the middle, or you can go faster, okay, really slightly adjustment, or toward us, like kind of, okay. This is really adding a lot of motion to the scene, and due to the repeat, we are adding all the time something to the action, okay. Then another boring things you should know. Here we are acting with a fixed texture. So a pixel format is a fixed 8-bit. Okay, what happens if we plug this? We have definitely more motion, but they are more hard to catch. Okay. And actually now we are, if you see, we are sending an 32-bit displacement to an 8-bit float. So if we push this again, okay, we have those tiny lines that we can barely see. We should actually reamp it, but I want to show you this. This guy, you can use it to make a lot of things that I guess you should already know, but you can just plug an edge, and it's really freaking cool to see. So we're edging a little bit less. Yeah. And you have this. Okay. I like it more in the other way, so I guess here, not sure, but we can try out the math and just multiply this a bit. Yeah, okay. Now we're having this. Pretty cool. Okay, so changing the actual input give us this, for the pixel input give us different results, the pixel format. Okay, so now we are sending an 8-bit displacement in a 32-bit texture. So, and if we pulse again the feedback, we go back to the things. Actually, it's not anymore as it was, because I multiplied it for a lot, pardon. Yeah, okay, so things you should know. Okay, that's it. Hope you like it. Make cool stuff with that, and subscribe. Ciao.